So on test 2, you know how some teachers are like, oh, you might see this on the test somewhere? F that. On the third page. On the third page. Not that. On the test that you get Wednesday, on the third page. Like page 1, you're going to flip it over. Then page 2, you're going to flip it over. And on the third page, question like number 15 or whatever it is going to say, solve this by substitution. Like, that's what it's going to say. And there's 2 questions that ask you to do that. I'm not saying maybe. Shit is. Solve by substitution. This is a classic solve by substitution problem. The reason why it is because it's already got y equals. When you solve by substitution, you have to get y equals something or x equals something. Now, in this case, both of them are y equals. That doesn't have to be the case, right? It could be 3x plus 2y equals 5 and y equals 2x minus 1. This is another solve by substitution scenario because all you got to do is you've got y by itself, so you just got to plug that in. So not all solve by substitution has y and y like this, but they all have either x equals or y equals something. And if they don't have it, it's pretty easy to get it. Okay? So let me get rid of this. I love that. One of my favorite things. How do you solve by substitution? Or you take this and you're going to substitute it in for y. So you're going to get negative x plus 3y equals 5/2 x minus 4. Now, someone asked me a really, really good question. And they said, well, I thought when you moved it across the equal sign, you had to change the signs. How come you didn't make the negative x positive x if you moved it across the equal sign? It's not moving it across the equal sign this way. It's taking this expression and substituting it. So it's a different little thing. But you get to here. Now, how do you solve that? Well, you got to get the x's on the same side, constants on the other. I'm going to multiply through by 2, and that will clear the fractions. Negative 2x plus 6 equals 5x minus 8. And now I'll proceed to solve. Adding 2x, adding 2x. 6 equals 7x minus 8. Add 8, add 8. 14 is equal to 7x. Divide by 7, divide by 7. X is equal to 2. Now, that only gives you half of the answer. Okay? That only gives you half of the answer. How do you get the other half? You go back to one of these 2 equations and you plug in 2. Now, I don't know about you, but I'll go to the one that doesn't have a fraction. Cheyenne's like, no, I want to do the one with a fraction. All right, well, you do that. Y equals negative 2 plus 3, so y equals 1. And so at this point, you would have the answer, which is 2, 1, and that would be what you put in the blank. And that is solving by substitution. Okay. Any questions on solving by substitution? Now, what if I don't tell you to solve by substitution? Then the other way that you can do it is elimination, and we're going to do that one here. 4x plus 3y equals negative 13, and negative 5x plus 2y equals negative 24. So a problem like this, what I got to get you to see here, Devin, is that if you try to do it by substitution, then you got to solve for one of these 4 letters. And notice that trying to solve any of these, trying to solve for this, or this, trying to solve those for either X or Y is going to ultimately produce a bunch of fractions that you got to deal with. Does that make sense? And now you're going to have Y equals some fractions, and then you're going to have to substitute that. It's going to be ugly. So we use an alternative method, and that method is elimination. Now, here's the way elimination works. Elimination requires that either the X term has the same numbers or the Y terms have the same numbers. And if they don't already have the same numbers, like if this is 3X and 6X, if they don't already have the same numbers, then it requires me to multiply by something that will make them become the same numbers. Does that make sense? Now, in some cases, and in most cases, I will point out, what we have to multiply might be different for each equation. Now, I don't know how many of you are like this. And my son's like it, and it drives me absolutely insane half the time, although I'm so thankful he is. He is a type A rule follower. He has been that way his whole life. How many of you are rule followers? Like whatever the rules are, you follow them. Z, for real? Cheyenne, are you? And it really bothers him if people aren't following the rules. Like, if he's following the rules and somebody else is not, he really gets pissed. Like, what the shit? I'm like, dude, it's okay. No, it's not okay. Some people want a rule. Tell me what to do every single time. If that's you, I'm going to give you a rule to do. Whatever this number is and whatever this number is, just multiply the other equation by it. Just multiply the other equation by it. With the caveat, that is, I need these to be different signs. So like, if I were doing the Y here, I would need to do, if I was going to do the Y, I would do the top equation by 2, the bottom equation by 3, but one of those would have to be a negative because I need to get the signs different, so they'll subtract and cancel. Does that make sense? If I'm doing it for the x's, they're already different and they're going to cancel anyway.
Do you want them to cancel?
You want them to cancel. So then one of these would have to be a negative sign. It doesn't matter which one.
Yeah.
Okay? All right, so I'm going to multiply top equation by 5, bottom equation by 4. And let's see what we get. 20x plus 15y equals negative 65. Do we agree?
Yes.
This is negative 20x plus 8y equals negative 96. Do we agree? And again, critically important that you're multiplying all 3 pieces. I'm going to star that because a lot of people will forget to multiply that last number. Am I boring you? I'm sorry. I'm doing the best I can. Thank you for the cover-up. Adding straight down, the 20's canceled. 23y equals that negative 161.
Yeah.
I believe him.
I did it in a calculator, so.
We're dividing by 23 and we get y equals negative 7. We agree on that? Right now there's a group of people going like this. If you say 161 over 23 is 7, then I guess I agree. It is. I wouldn't lie to you. I did it last week. All right. What do you do with the y value once you know it's negative 7? Plug it in. You know, somebody ought to make a commercial where they just talk about plugging it in. It'd be great for like a fragrance thing, you know? Like if your room smells, you just plug it into an outlet or something. That would be a really good idea. 4x minus 21 equals negative 13. Add 21. 4x equals 8. And then you get x equals 2. Does that make sense? So what do you write in the blank? 2, negative 7. That would be the answer. Now, there's a video where I detail for you some special cases. When you solve this and it goes wrong, like that could be a whole damn YouTube series when math equations go wrong. All right? But there's a whole video I created last week that is in Canvas about when it goes wrong, what do you put? No solution, identity, and all that stuff. So I'm going to leave you to look at that. But in the time being, I want you to try number 8 and number 4. In the time being, let's try 8 and 4. 8 is y equals negative 6x minus 3. And x and y equals negative x plus 2. That is 8. And 4 is 6x plus 7y equals negative 9. And 4x, negative 4x minus 5y equals 5. I'm going to press pause here. We're going to pause for station identification and for the following commercial break. Eat more chicken. So for this, it's just straight substitution. Take this, plug it in here. Negative x plus 2 equals negative 6x minus 3. Adding x, 2 equals negative 5x minus 3. Add 3. 5 equals negative 5x, and x is equal to negative 1. Hopefully we all agree on that. Taking this and plugging it in, negative 1 plus 2 equals 3. So your answer is negative 1, 3. And that's what goes in the blank. For real, is there a question?
Hold on a second. Yeah, when you plug in the x, wouldn't that just make it negative 1 plus 2?
It's not negative 1, it's negative x. So it's negative 1. X is negative 1. This negative that you see here and this negative that you see here are not the same ones. There's 2 of them. Doesn't matter where you plug it into, I guess. What happened?
I got negative 1, 1. Well, I got 1, 1, and then I saw the negative, so I put the negative there.
How did you get 1? If x was 1, you would get positive 1.
I put the 1 into y equals negative x plus 2.
Now, how did you get x equals 1, though? That's the question. Like, I'm not being a jerk.
I got x right, but I didn't get y right.
But x is negative 1.
Well, yeah.
So you didn't get X right. Like, I'm not trying to be a jerk or be condescending or anything.
I just missed the negative sign on the 5, that's why.
Okay, that's fair, right? But my point is, if you got X equals 1, then you would get Y equals positive 1, because when you plug it back in, you're going to get positive 1.
That's what I got.
Right. So if X were 1, then you'd be right.
Yeah,
But X is not 1. X is negative 1.
that's why I was wrong. So it would be, okay, just be 1 plus 2.
Yes. Yeah. All right. Now, some of you want to try to eliminate the X or the Y here. It doesn't really matter. Okay. If you do the X, now remember what I said. One way to do it is just to take whatever number you have here, put it here, and whatever number you have there, and put it here. I apologize, you cannot see my pointing. But what I was pointing at was whatever number you have here, put it there, and whatever number you have here, put it here. Okay? Somebody in the last class said, well, wouldn't it be easier if you just did 2 and 3? If you made this 2 and made this 3, wouldn't that be easier? I don't know. Is multiplying by 2 easier than multiplying by 4? If it is, then I guess it's easier. If it's not, then I guess it's the same. The reason I like to do the 4 and the 6 is that stays consistent with my message. Just change the damn numbers and multiply top and bottom by those. Okay, if I do 2 and 3, now I'm telling people you got to think about it. That's not good. Not good. Do not want a classroom full of thinkers. We want a classroom full of people who just do what I tell them to do. Fahrenheit 451 or whatever it is. I was supposed to read it. I watched the movie. 24x plus 28y equals negative 36. Negative 24x minus 30y equals 30. We agree?
Yes.
Negative 2y equals negative 36. JK? How about negative 6? And y is equal to 3. Now, somebody asked me last class, when I get y equals 3, does it matter what equation I use? And here's the bottom line. You have 4 equations. 1, 2, 3, 4. It does not matter which one of those 4 you choose. Now, I actually had a high school teacher tell me that it makes a difference because if they plug it into 3 or 4, if they didn't do it right the first time, then this equation is not even right. So they're plugging it into a wrong equation. And for the life of me, I'm trying to figure out why it matters where you plug the wrong answer into. Because if this equation ain't right, that answer probably ain't right either. So now you got a wrong equation. Plug it where the hell you feel like it. Hell, make up an answer for the next one. It don't even matter. Put 3, no solution. Plug it in y. 6x plus 7 times 3 equals 9. 6x equals 9 minus 21. So 6x equals negative 12. 6x equals, sorry, I'm thinking about lunch, negative 30. And x equals negative 5. I'm going to stop here.